Hello. Let's go ahead and divide these two Gaussian integers. Let's divide 7 plus 3i divided by 2 minus 3i. And let's do it in an base I exploding dots machine where our boxes are just 1, I, -1, and -I. So here we see that we represent 7 plus 3i in our circular exploding dots machine, right? We just have 7, so that's just 7 ones, 7 dots in our ones box, and then we have 3 dots in our i's box. So there we have 7 plus 3i. Now we're dividing by 2 minus 3i. So that means we want to find how many groups of 2 minus 3i do we have in 7 plus 3i. Well, what does 2 minus 3i look like? Well, here we see it right here, right? 2 minus 3i, that's 2 dots in our ones box, and we have 3 dots in our negative I box. That's 2 minus 3i. Okay, so I guess the pattern we want to find here is 2 dots next to 3 dots, and we're going, I guess, in the counterclockwise direction. Okay, do we have any 2 dots next to 3 dots? Again, in the counterclockwise direction. Well, yeah, right. There's definitely a group right here, right? There we have 2 dots next to 3 dots, right? And that would be basically where we originate. So that would be at the i's level. So we have one group of 2 minus 3i at the i's level. Any more? Well, no, right? I want 2 dots next to 3 dots going in the counterclockwise direction, and I don't see another pattern right now. Okay, but, can we create another pattern? It looks very tempting because what do I have here? I have 3 dots, right? I actually have 4 dots, right, in my ones box. So, right, and I have 1 dot in our i's box. So what do we need to create another one of these patterns? Well, we just need another dot in our i's box, right? So all we have to do is, well, go ahead and, put a dot in our i's box. There's something in life you want, go ahead and make it happen. But you have to deal with the consequences, right? I can't just go ahead and willy-nilly put a dot in my i's box, right? Then I'm changing and I no longer have 7 plus 3i. But right, if I add an I and subtract an I at the same time, well, then I really didn't do anything. So I could add an I, and if I add a dot in our negative i's box, well, that's like adding an I and subtracting an I at the same time. So I still have 7 plus 3i, but now I see another one of the patterns that I want. I want 2 dots next to 3 dots going in the counterclockwise direction. And oh, there we have it, right? There is another 2 dots next to 3 dots, again in the counterclockwise direction. And well, okay, is there anything else I can do? Well, I have 1 dot in my ones box, 1 dot in the negative i's box, and well, I guess I could create, another pattern if I really wanted to create another pattern. But then I'd have to add more dots, and I probably would end up with more dots, right, than I have now. So I think we might be done. And well, okay, then what is the answer? Well, we're seeing here, right, that 7 plus 3i divided by 2 minus 3i, we have 2 groups of 2 minus 3i, both at the i's level. But then we have these 2 dots left over. So it's looking like we're saying that 7 plus 3i divided by 2 minus 3i, that's going to be, looks like it's equal here, right? We can just see it. We have 2 i's. This is going to be equal to what? Well, 2i, but then plus some kind of dots left over. That's our remainder. And we have 1 dot at the ones level and 1 dot at the negative i's level. So it looks like here we have a remainder of 1 minus I, right? 1 dot at the ones, 1 dot at the negative i's. Okay, so if our quotient, right, our answer to this division problem is 2i, remainder 1 minus I. If that's true, just like in ordinary division, when we divide the dividend by a divisor, we get a quotient. Well, then we have to have that the divisor times the quotient plus the remainder should be equal to the dividend. Right? Is that true in this case? Well, let's see. We would have the quotient times the divisor. So we'd have 2i times 2 minus 3i, and then plus the remainder, so plus 1 minus I. That should be equal to 7 plus 3i, if we're correct. Is that true? Well, let's go ahead and check. 2i distributes, we have 2i times 2, so that's 4i, and then we have 2i times a negative 3i. So 2 times negative 3 is a negative 6, but then I times I is I squared, which is equal to negative 1. So we have negative 6 times negative 1, which is plus 6, and then we have this plus 1 minus I as a remainder. So there is the quotient times the divisor, and then plus the remainder, so plus 1 minus I. Well, that's equal to what? We have 6 plus 1, which is 7, and then we have 4i minus I, which indeed is equal to 3i. So yes, this checks. This indeed is equal to 3 plus 3i. So yes, our answer here of 2i, remainder 1 minus I, must be correct. Take care.